Thanks. I'm glad to be here and glad to be talking about this. This work, in large part, is supported by a program at NOAA called RISA, which is the Regional Integrated Synthesis and Assessment Centers. And what the really exciting thing about working at the RISA is the ethos there of transforming data into knowledge. So going from the numbers to the insights to the decisions. And one of the ways that we're working on that is we're doing projects that we call co-production of knowledge. So we're trying to think about how do you bring scientists, stakeholders, citizens, canal operators, how do you bring them all together to think about solving the problems on the landscape? And of course, one of the ways that we do that is through models and model buildings. And that's what I wanted to talk to you about today, is this technique that we're using. But before I get started, I want to lay the groundwork with some definitions. And one of the first ones is this idea from planning is that what we're working on are wicked problems. And wicked problems are those problems that don't stand still. They don't even stand still long enough to give ourselves a chance to say what the problem is. Because as we all know, we're working with complex systems that are dynamic and they're continuously changing. And the stakeholders all come to the problem that we're working on with different viewpoints, different ways of understanding the problem, and even different senses of what a possible solution might be. So even as we're working on these problems, the constraints, the science changes, everything starts to keeps changing along with the problem. So we never ever get to a solution, definitely. And finally, or not finally, now we have these things that people are calling our super wicked problems, climate change being the first example. And this idea is that time is really running out for us to find solutions. There's not a central authority for someone to be making the final decisions. There isn't a central authority for anyone to convene, to bring us together. Those who are trying to solve the problem are also causing the problem. My favorite thing is to ask climate scientists why they keep getting on the plane to go to modeling conferences when they know it's probably the most dangerous thing that they can do as an individual is to get on a plane. The other problem is that the policies tend to discount the future non-rationally, and so we're in this sort of super wicked problem, and we try and think about, well, then what can possibly be the role of science as we know it? And so the other thing I want to think about is this is a great figure from one of my modeling friends who says when we think about the future, we have to be really honest with ourselves and realize that the further out we go, the more unlikely we are to have any real answers, but to be able to start thinking about what that possible and probable spread looks like in the not so distant future any longer. So we want to think about what the role of science is in these kinds of wicked problems. Thomas Kuhn talks about something that he called normal science, and that's where the system uncertainties and the decision stakes are relatively low, and we're able to do relatively positivistic science that we're all used to. And this is the kind of science that has changed the world and will continue to change the world. However, as the system uncertainties go up and the decision stakes go up, we move into a different kind of mode of role of science that's called professional consultancy. And I think of the IPCC as the grand example of this kind of science where we're bringing experts together to try and reach a consensus on something that we don't quite have a handle on around yet. However, as you go out even further where the decision stakes are really high and the uncertainty is really high, we have what people are starting to call post-normal science, is what are we doing out there on the edge? So when we think about post-normal science, it looks a lot like the definition of wicked problems, where the facts are really uncertain, we have disputes about the values, we have less than the amount of information we'd really like to have. We're always going to be faced with uncertainties. And that last bullet there is that the mistakes that we make can be really costly or even lethal at this point. So when we're thinking about this is the environment that we're working in as scientists. So when we think about how we cope with wicked problems in this post-normal environment, is we have three sort of approaches. And one is authority, is that you just give the responsibility for dealing with the problem to someone and just say, fix it for us. Another is competition, and this is really all the talk about market solutions, is we put it in the market and the market will fix it. And sometimes it can, and sometimes it does. And the third approach is collaboration, where we bring together the people who are part of the problem and part of the solution to try and work together. So I have a colleague at Arizona State, Dan Sarowitz, who asked me once, can we substitute process for uncertainty or for certainty in resolving wicked problems? I think scientists have made a fetish of uncertainty and certainty, and it sort of is it paralyzes us sometimes for making recommendations or getting involved in policy problems. But here's a real interesting thing to think about. Could we substitute process for certainty when we're thinking about wicked problems that we have to make a decision about? So one of the things that we're working on at CIRC, which is the Climate Impacts Research Consortium, again funded by the RISA program at NOAA, is finding a way to create these boundary organizations that will help us integrate science and policy. So we start by forming a research agenda around the needs of the stakeholders. We don't go in as scientists saying, here are the problems. Instead we say, what are the problems? How do they work? And then we start to assemble the needed expertise. We don't go in saying we know what needs to be done. We ask what needs to be done and then start bringing those people together in a team. And then we start developing the decision support tools that will answer the questions that they have. So here are some of the recent areas in the Pacific Northwest where we've been working on this project. And they're everything from very small projects, like up in Skagit County, and to very large ones, like the whole Willamette Basin in Oregon. So the modeling platform that we use is something called Envision, and it's as complicated as any of the ones that we have here. And the idea is that we are using not just plug-and-play components to the modeling platform. We're also asking people to start developing alternative futures, including preferred alternative futures, to think about what it is they want the future to look like. This Envision is an agent-based model, and the agents are moving around based on the preferences that the stakeholders are selecting for themselves. So the process that we use is one of these scenario planning processes that you've seen. And the thing for us is that it's very iterative, is that we're often trying to think about things, we're exploring things with stakeholders, we're coming back, we're asking more questions, and we're continuing to interact constantly with the stakeholders as we develop the models. So this is an example of a project that we did in the Big Wood Basin in Idaho. The Big Wood Basin, at the top of the basin is Sun Valley Ski Resort, which with many second and third homes for very wealthy people who fly in to go skiing in the winter. At the bottom of the Big Wood Basin is basically low-value agriculture for dairy farming in other parts of Idaho. So there's this real gradient of wealth and power and other kinds of variables that are important when you're making decisions. So we brought people in the Big Wood Valley together, and we started out by asking them, what did they want for the valley over the next 50 years? And so we came up with this series of endpoints, and then we worked together in small groups where people were developing a conceptual model that looked something like this. This is one of those spaghetti models that our stakeholders actually drew themselves in about 2 hours of working together, trying to think about how it was that their understanding of how the Big Wood Valley worked or basin works. We turned it into this model, and these were the endpoints that they were interested in. These were the questions that they were asking. After more conversation with the group, here we go. After more conversation with the group, we decided that these were the 3 kinds of questions that we could probably address in a relatively short period of time. And so these were the ones that we went after: sufficient water for ag, aquatic habitat, and responsible development in the basin. So the other thing that we needed to talk about was what were the alternative scenarios that people wanted to think about for the future of the Big Wood Basin. And we did 4 future scenarios, one that they were based on the economic structure. Was it going to be tourism, or was it going to be agriculture? And then how managed was it going to be? So we had these 4 alternative scenarios. Then we worked with the climate modelers at the University of Idaho and asked them to downscale the regional models to take a look at what it would look like in the basin or relatively close to the basin. And so all of the time this is going on, working with the stakeholders, they're interacting with the scientists, they're posing questions to the climate modelers, they're looking at the output of climate models in the region. And so we're building a lot of capacity in these stakeholders to look at scientific information and think about what it might mean for them. Ultimately, we decided to select 3 of the climate models that would be big change, medium change, and low change, which is not much of a surprise. But when you cross the climate models by the management scenarios, all of a sudden we have 12 different future scenarios that we're working with. So we have a lot of models all of a sudden. So we go back to the Envision modeling framework, and we put the downscaled data in, and we put in a bunch of other models, including the hydrology models, the population, land use, water use, and ownership models. And so, again, this is an agent-based model that we built the policies right into. So one of the things that happens with a model like this is it starts to put the data out, and we're not exactly sure what's important any longer. So remember, we have 12 potential futures that people are looking at. So we think about some of the kinds of information that come generating from this model this is high elevation April 1st snow water equivalency. So this is really important in the basin. It's important for the ag end as well as for the tourism end. We also can look at models at different ways. So here we're looking at them at different elevations for the snow water equivalency. Another kind of things we were looking at frost-free periods in different parts of the basin. So this is just a really simple example of some of the data that were coming out, and we're trying to figure out what do we do with that? How do we deal with it? So one of the things that we've been able to do, and let's see if this will work, is we're creating, guess I can't get on here. I can't get onto the Wi-Fi here unless I have a password. Okay. I'm sorry that I can't show this to you because I want to give you a sense that what we started to do is we've loaded all of the data, all of the metadata into this atlas. And we brought it back to the stakeholders in a series of meetings, and they just looked at us and said, what do you want us to do with this? And we weren't sure what we wanted them to do with it. So we brought it back to Corvallis, to Oregon State University, where most of us were working, and scratched our heads for a while, and we said, what's going on? What's the story? And actually, that was the answer, is what's the story? And so we said, what are the storylines that are important here? And what we had to do is we had to sort of reduce all of those model runs, all of that information that was coming here into these stories that made a difference or that were important to our stakeholders. And so I wish I could show you this, but you can see that one of the places on the Big Wood Data Atlas is a storyline, and you can pull that down. And if you're interested in snow, there's a whole storyline about snow that has all of the data there, and it has all of the data for all of the different preferred alternatives. It has all kinds of information for you. So we have those storylines, so we brought those storylines back, and all of a sudden it started to make a difference to the stakeholders that we were working with. And I should have said this before, but the stakeholders in the Big Wood Basin included elected officials from local communities and counties, federal agencies, state agencies, the private sector as represented by the ski resort and by the canal companies. And we also had individual farmers who were participating. So we had a wide array of capacity, education, income. They were all sitting in the same room trying to make these decisions. One of the things I want to talk a little bit is about the lessons learned as we're working with these models are all of the kinds of things that we've been hearing about today. And it's really a balancing act as we try to put these models together for the stakeholders. Somebody said earlier that it needs to be useful, it needs to be usable, and you have to find that sweet spot between being really complex and being really simple. And that's one of the struggles that we continue to find. I'll tell you that the scientists, and I'm one of them, love the complexity, but when we brought it to the community, they just shook their heads at us and said, we can't do anything with this. What do you want? What do you want us to do with it? So when we think about the project designs, and we've heard this before, is that the integration needs to come at the beginning, not at the end, is that you need to bring all the players together at the beginning and know that it's going to take some time for even the problem to get framed at the beginning before you get started. I think one of the things that is sort of implicit today but isn't being said out loud is that we need more systems thinkers. And that means at the university, we need to be training people about systems because that's what we're working with now. We're working with complex systems and we're working at integrated systems, and we're not yet all of us thinking like systems. I think we also we've heard that we need to do this multidisciplinary approach. And the other thing that we found is that the place really matters. And we heard that earlier today too, is that the behavior of the ecosystem and the social system and the economic system and the climate are all place-based, and they're all reacting differently in different places. So we found that it's really critical for us to get involved in the place. The other thing that we've learned about collaboration is that the team dynamics, personalities really make a difference, because boy, if there are assholes on your team, forget it, forget it. The other thing we found is that the culture of science can really be both a plus and a minus. We really need solid scientific footing to be useful, to be credible, but sometimes disciplinary scientists cannot think outside their box, and that disciplinary thinking can really put boundaries on the way we can move forward. So there is that tension around the culture of science. I would also say that the stakeholders that we've worked with, and I've worked with stakeholders all across the country, are not only interesting, but they're pretty knowledgeable people. And most of the stuff that we're doing is really not rocket science, and they can figure it out pretty quickly, and they can help us think through what's going on. I would say find out who the thought leaders are and engage them early and engage them continuously. The last thing I want to talk about is the communicating usable knowledge. It turned out that this was a massive undertaking, is to figure out what it was and how to communicate it. I think one of the most important things is to make the assumptions and the choices that you make in the modeling transparent to people. We make choices all the time, we make tweaks, we condition our models all the time, and that's what makes them black boxes to most people. But as long as we let people know what we're doing, it all seems to be kind of acceptable to them because they understand it. I think addressing really important issues and questions, there's a lot more tolerance for problems in the models when they're addressing questions that we're interested in and that are important to us. The other thing is we need to create simple visuals. We have a grant from NSF to try and build visualizations of complex data, and I have to tell you, some of those two-dimensional visuals are probably as powerful as we need to get. That sometimes when we get into the fancy visuals and even the animations, that we lose people pretty quickly, and we have to spend as much time explaining the visual as we do explaining the output. We also found that we needed to provide options and easy interfaces for people to be able to explore things individually. So we needed to provide them directions and instructions and metadata and explanations of how to use the data interface. And there is that thing, is how do you find an intuitive interface for these models? We found stories as the way to go. We're using storylines for all of our alternative futures projects right now because we can't think of anything better. If there's something else out there that's better, we're ready to grab onto it, because the story narrative thing is working right now, but we're not sure how robust it is or how long it can hold these stories. And again, provide access to the data for your users. It seems to really reduce some of the angst that people have about the model and the model output. And that's it.